So today, and we're getting started with our next unit, and this is going to be all about Lewis structures and how to draw atoms and molecules. So let's do a quick review of just what it means to draw a Lewis structure for an atom. So let's start off with, say, lithium. What we need to know for lithium is that it has one valence electron. And how do we know that? Well, we can look at that one of two different ways. Let me get that back here. It's got an electron configuration of 1s2, 2s1, so it's got that one highest energy electron. Or we could look at it where it is in the periodic table. We see that it's in group 1 and period 2. So group 1 all have one valence electron. Okay? So what we're going to do with lithium, its one valence electron means it gets one dot. That would be lithium's Lewis dot structure, or Lewis dot diagram. For something like nitrogen, which has 5 valence electrons, you'd go ahead and draw nitrogen, and then 1, 2, 3, 4, 5. Now, it doesn't matter which way you start, or in what order you put the electrons in, just as long as you make sure that nothing gets paired up until there's no more empty sides. Alright? So I wouldn't be able to draw nitrogen like this. 1, 2, 3, 4, 5, not right. Okay? We need to make sure that everything gets one electron. Each side gets one electron before we start to pair anything up. Similarly, you draw fluorine with 7 valence electrons like this. You get fluorine, 1, 2, 3, 4, 5, 6, 7. Alright, so showing that we've got pair, 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 and then one extra electron over here. Okay, so that's basically how to draw a Lewis structure for a neutral atom. Let's take a look at how we do it for an ion. So, magnesium. Magnesium starts with 2 valence electrons. So, we draw magnesium like this. But when magnesium is in a bond, say it's in magnesium chloride, then what we have is magnesium plus 2 and 2 chlorides, which are both chlorine minus 1. Well, let's think about what happened to magnesium. To get a plus 2 charge, it had to lose those 2 valence electrons. So, instead of having its 2 valence electrons, magnesium is without its any valence electrons. It doesn't have any of its previous valence electrons. So, the way we would draw magnesium would be like this, and since it's got a charge, we're going to put it in brackets with the charge outside. Now, let's think about chlorine. It's got 7 valence electrons. Chlorine, 1, 2, 3, 4, 5, 6, 7, okay? When it's in magnesium chloride, it now has a minus 1 charge, so instead of being 7 valence electrons, it's gained 1 more. So, chlorine, 1, 2, 3, 4, 5, 6, 7, and I'm going to make this one a little different. I'm going to give it an X to show that it's actually got 8 electrons now. And again, it's got a charge, so we're going to draw a bracket around it and give it a -1. Well, sorry, let's shift this around. There are 2 chlorines in it, so 1, 2, 3, 4, 5, 6, 7, 8. So magnesium chloride with 1 magnesium, 2 chlorines. Since these guys are ions, they get brackets around them with their charges. This would be how we draw the Lewis structure for an ionic compound. We'll show you one more example. Say for, how about, keep it simple, Na2O. Alright, well, sodium normally has 1 valence electron. Oxygen normally has 6 valence electrons. So we would normally draw sodium like this. And we'd normally draw oxygen like this. 1, 2, 3, 4, 5, 6. Well, in a chemical, in sodium oxide, you have Na plus and O 2 minus. So what we need to do to get a +1 is lose that 1 electron. So we'd actually have no valence electrons, at least at the previous energy level. They've all dropped down to the second. All right, and we've got another one over here. We have 2 sodiums, brackets around them because they have charges, and this oxygen. 1, 2, 3, 4, 5, 6, and it's gained 2 more electrons, so it has a -2 charge. So that's how we would write a Lewis dot structure for an ion, and then for an ionic compound. We're just going to draw the individual ions and put them next to each other in brackets. Things get a little bit more complicated when we start talking about covalent compounds, because remember, covalent compounds actually share electrons. Okay, they share electrons as opposed to gaining and losing them. So let's look at a really simple example. How about H2O? Well, we start by drawing out the individual atoms. Oxygen and hydrogens. We've got 2 hydrogens. Now, I'm drawing these a little bit differently. Okay, one's got an electron on the left, one's got an electron on the right, and we'll see why. Now, I know the obvious question would be, how do we decide which one goes in the middle? Generally, all right, if there's only one of an element, it'll go in the center. If it's carbon, it'll go in the center. And lastly, generally well, it's not really a good rule. We're not going to worry about introducing that one quite yet. When we start talking about polarity, we'll introduce another one. For now, if there's only one of an element, or if it's carbon, those are going to be the ones that go in the middle. All right, pretty much everything else we're going to worry about later. Now, what we want to do is make sure that every electron gets paired up. Let's think about that. We're trying to follow the octet rule, which states that everything wants 8 valence electrons. Well, if we look at oxygen, it's got 1, 2, 3, 4, 5, 6 valence electrons. And we know that this is going to be sharing electrons somehow to make a bond. Well, it would need to share an electron to end up with another one right here, and it would need to share an electron to end up with another one here. So what we're going to do is look out for places where there is an unpaired electron. This would be a paired electron. This would be an unpaired electron. So what we're going to try and do is match up paired and unpaired, or excuse me, we're going to try and match up unpaired electrons from adjacent atoms. I see one here, and I see one over here. We're going to match those up. I see one here, and there. We're going to match those up. Now, this is the second to last step of our process. To draw a good Lewis structure, we're going to replace all of those circles with bonds, with basically a line. Now, so we can go ahead and draw our oxygen. It's got a bond out to this hydrogen. It's got a bond out to that hydrogen. Inside each one of those bonds is 2 electrons. Okay. 2 electrons per bond. Okay. And so let's count the electrons around oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is happy. It's got 8 valence electrons. Now, you'll notice that hydrogen only has 2 valence electrons, which is actually okay. Hydrogen, you're going to find, is one of the exceptions. Okay? It's an exception. It's happy with 2 valence electrons. Hydrogen is happy with 2 valence electrons. Helium is the other one that's happy with 2. The only other exception that we're going to see on a regular basis is boron, which is happy with either 6 or 8. So we're going to get a lot more practice with this one. We're going to show you one more example and then close up for the day. There we go. All right, last example. Let's try something that we'd be able to do. How about this one? Let's use NCl3. Okay, so we see that nitrogen, there's only one of them. There's 3 chlorines, so we're going to draw nitrogen all by itself. 2, 3, 4, 5. And then what we want to do is arrange the other atoms around it in as symmetrical a fashion as we can. Okay, we want to be symmetrical. So I see a chlorine, 6, 7. I see a chlorine, and I see a chlorine. Okay, so what we want to do is pair up any unpaired electrons, and it doesn't really matter where they are on the individual atoms. Let's start off with the easy ones. We can pair those unpaired electrons. For here and here, well, we can pair those. Those are unpaired electrons. We can also pair those. Those are unpaired. Notice how it doesn't really matter which way these electrons are facing. We can always do the rearranging when we get into drawing the actual molecule. So let's go ahead and do that. We've got nitrogen, and it's got those 2 paired electrons up here. Now what we're going to do is draw bonds between the nitrogen and each of the chlorines. Now we're actually ending up having to rearrange a little bit, but let's just take a look at this chlorine. It's got 3 pairs. 1, 2, 3, 4, 5, 6, 1, 2, 3 pairs. This one also has 3 pairs. 1, 2, 3. So let's just put those around. This one also has 3 pairs. We don't need to do any rearranging with that one. Count. This chlorine has 2, 4, 6, 8 electrons. This chlorine, 2, 4, 6, 8 electrons. This chlorine, 2, 4, 6, 8 electrons. This nitrogen, 2 all to itself, and then it's got 2, 4, 6 electrons in bonds, which means that this nitrogen is all happy, all right? Which means that everybody has 8 valence electrons, okay? So all are happy, all right? We're going to be getting a lot more practice with drawing Lewis structures as we go. Hope this helped. We will see you back in class, and we'll get another look at this and a couple more complicated things as we go.